Please welcome our next speaker, Kasper Nossent, Managing Director of DyeCoo Asia, with a presentation, Water-Free and Process Chemical-Free Dyeing, Introducing the Green Revolution.
Thank you. Good afternoon, everybody. In the coming 20 minutes, I try to talk you through what we hope is the next revolution in polyester dyeing and future also for nylon dyeing without water and chemicals. If we look at the current world and we look at where we have the availability of fresh water, then we see a lot of competition heading our way in the availability of fresh water. And if you look at this diagram, you will see that the availability of fresh water in Asia is still pretty good today. But if you look at 2025, we are heading into serious water shortage problems. And that's the availability of fresh water for everybody, not only the industry, but also general members of the public. If we look at the growth of the current textile industry, we look at growth in garment usage, which is expected to grow significantly over the coming decades, and also the use of fabrics in general. Everything is manufactured predominantly in Southeast Asia, so we do head to a big problem. We are the most polluting industry in the world, or one of the most polluting industries in the world, and we need to change. And it has to change on several levels. We'll see a lot of initiatives coming up on the garment side, but we try to do something different on the mill side. And what we try to do is we try to be different. We cannot solve problems by using the same methods that created them. And we want to do something radically different. Instead of using less water, instead of using less chemicals, we are going to do something that doesn't require a single drop of water and doesn't require a single chemical to be used in the dye process. And ultimately, we don't use any water, and we also don't generate any wastewater in the process of dyeing fabrics. How do we do that? Well, we have chosen to use carbon dioxide, which is abundantly available in the environment. It's easy to capture, and it is widely available through industrial gas vendors in a liquid form, and that's actually the form that we use as the basis. In our process, it's fully recyclable. We use about 95% recycling rate, so we keep recirculating the CO2 in our process. It's inexpensive, it's available everywhere in the world, and the good thing is it's the same quality anywhere in the world. If you take liquid CO2 in a pure form, it's the same in Vietnam, it's also the same in the US, and will be the same in Colombia. That allows you to actually move easily around your dye recipes to different mills you operate around the world, and you don't need to change anything in the recipes as long as you keep the fabrics the same. What is the good thing about supercritical CO2? Because that's the phase that we use. In that phase, we can actually disperse dyes in their natural form instead of using dispersing agents or other auxiliary agents to keep them in dispersion or even to dye a hydrophobic fabric like polyester. In our case, we also use pure dyes. We only use the dye stuff. We don't use any additional chemicals added to the dye stuff mixture. So what does that do? Well, of course, no water, no process chemicals. Those are the obvious ones. The other thing is we don't generate any waste. So the fabric goes in dry and comes out dry. There's no additional post-treatments required in terms of heating because there is no water to evaporate in this stage. The consistency of CO2 and the ease of repeating the dyeing process, because we don't have a starting position where there are variables that can change like you have in water dyeing, our batch-to-batch repeatability is close to 100%. And that 1% is due to the fact that we still use manual labor to actually load and unload fabric and to choose fabric and also to load dyes. It's a relatively quick process. With CO2 dyeing, you can dye approximately between 2.5 to 3.5 hours any shade you want. Lighter shades even require a leveling time of less than 20 minutes, which will break the economics of the system as well. So if you look at the average savings, and this is just one of the examples that I want to give today, this is one of our machines operating on a very modest 2.5 tons a day output. And these are just the savings that you can achieve just by using that system. The amount of water that you save on an annual basis equates to 15 to 27 Olympic swimming pools. This one machine. Total chemical savings, in general, we save up to 100% of any chemicals used in the dye step. This equates to a significant amount just for one machine. If you imagine that one machine that runs in full operation, in our case, we use about 7.5 tons of dyes on an annual basis. If you would take into account that in a normal dispersed dye recipe, about 60 to 70% of the weight is additional chemicals instead of dye stuff, you can imagine how much chemicals we actually save on an annual basis that don't end up in wastewater treatments, and in the worst case, don't end up in freshwater systems. So how do we do that? We are the first company so far in the world that make this into an industrial process. Rather than doing it on a lab, we actually made a machine that can do this on a large scale in the industry. And what we need to do is we need to take liquid CO2 and bring it to what we call the supercritical phase, which is the fourth state of matter. And in that stage, CO2 acts both as a liquid and a gas. So we have the properties of a liquid, but also the properties of a gas. And those go hand in hand because we've got deep penetration into the yarn and into fiber levels. And we still have high solubility because the density of the fluid is extremely high. It's close to the same as the liquid form. So what we do in our machine, we store liquid CO2. We bring it to a dyeing vessel, pressurize it, and after dyeing, we cycle it back through a separator where we actually separate dyes, any oils that we take out of the fabric, and we take clean CO2 back into our main storage vessel, and the rest is a little bit of waste that we collect in our separator unit. So in a nutshell, the main components of our machine and the technology is based on storing liquid CO2, a dye vessel where we use a beam dye process, a separator unit to actually recycle 95% of our CO2, and after dyeing you have a dry, clean piece of fabric. And you don't need to do any post-reduction clearing steps with chemicals to achieve your fastness properties. The moment the fabric leaves the machine, it is ready to be used. So how does that look? Well, this is a graphic image of how the machines look. And you see they comprise about of 3 dyeing vessels. And the unique proposition that we can bring to the market is that we can dye both fabric in knit or woven form and also yarn in the same machine. And they all follow the same protocol. It goes in dry, comes out dry, and you can go straight to post-processing if needed. And if there's no post-processing needed, you can go straight to your quality control and dispatch the goods. Here you can see the unique capability where we have 3 dye vessels. One is being used for dyeing yarn, the other one is used, or the other 2 are used for dyeing fabric. This can all go on simultaneously, and that actually provides a better use case for the machines because the flexibility goes up. You can use any product that you have in this machine. We started off roughly 10 years ago by going to market with a first idea. And before we got anywhere, it took us to 2010 to get the first prototype out in the market, which was a single tube prototype that we installed in Tongshan in Thailand. Shortly after 2012, we had our first generation 2 machines in the market. And now, 2019, we sold the last 2 generation 4 machines, bringing the total to 14 machines to date. So we grew significantly, but we're also the only pioneers in the market that currently work towards commercialization of the technology. And in the last 2 years, we made significant progress, and we now sell our generation 4 machines, making it the state-of-the-art in dyeing for polyester. The factories that we look at, and the factories that I start using these machines, they look like clean rooms. They look nothing like the traditional wet, humid and dirty dye houses we all operate in. They look like clean rooms. There's not a single drop of water used in the whole facility. The current factory that we have an artist's impression of here is a factory that operates in Vietnam. That's the first only CO2 dye house in the world. It's operated by a Dutch company called Clean Dye. But the next step will be that we also try to eliminate post and pre-treatments based on water using best available technologies. And maybe in the future we can replace some of those as well with carbon dioxide. So in the end, sustainability as such is not a business model for a mill owner. They need to make money with it as well, and they need to recoup the investment. And that's where we come in as well, because using CO2 dyeing, depending on where you are in the world, you can have significant savings in your operational cost. Not only on the savings on dyes and chemicals, less energy used, but your overall variable cost can be 30 to 40% less than your current jet dye programs or underwater-based processes that you use. One of the things that we ran into when we started this was there were no dyes. The dyes that we use are dispersed dyes, but they're soluble in CO2. So we needed to find dye stuff partners that were willing to look into what dyes they can find that are soluble in CO2 in a rate that is acceptable for an industrial process, because low solubility means that the dye processes go up significantly. So we found our first partner, Colotex. We've been working with them for 15 years now in developing dyes for CO2 dyeing. And they currently have 23 to 24 dyes available in single shades. You can blend them in any mixture you want. And the gamut we can cover is basically anything that we need, from neon colors all the way down to deep, dark Nike black. And We expanded our collaborations towards DyeStar with Huntsman and Achroma as well, just to expand the amount of available dyes and also look into developing new dye stuff chemistries for example, nylon dyeing together with Colotex, but also with Huntsman in automotive dyes and with Achroma and DyeStar in regular dyes for apparel fabrics. Over the years, we've seen slowly progress towards the brands picking up and starting to brand the use of CO2 dyed fabrics. In the beginning, we had a brand called Dry Dye. That's where it all started. It was a Tongshan-owned hang tag label. And quickly after that, Nike launched Color Dry, which is a proprietary Nike brand for any fabrics dyed in CO2 using DyeCoo machines. Now we closely collaborate with Gap, PVH, Mizuno in order to bring more products to the market that they actively brand as being dyed in CO2, or they take it into their larger overall global goals for water saving and report that they reduce significantly the water footprint or the use of chemicals in their supply chain. At the moment, the first company that goes into full-fledged CO2-based products is Clean Dye. They are now only offering garments made in CO2, and their business model is geared towards only using retailers as their outlet at the moment, but that is only garments based on CO2. All the other vendors that we currently work with, they still have a balance between water-dyed and CO2-dyed materials, but we hope that that balance will shift over the years towards CO2 and extreme low liquor or water-free dye houses. So we would like to thank you for your attention, and hopefully you want to join the revolution for a cleaner and better textile future. Thank you very much.
Any questions to our speaker?
Hi. Are there any limitations based on different constructions? For example, we've heard that dense wovens have leveling issues between the outside and the inside of the fabric roll.
So in general, the construction is not a limitation, but the example that you give for very lightweight, high-density taffeta fabrics, yes, there is a limitation, but that limitation is more towards the permeability of the fabric for either a liquid or a gas. So in water dyeing, it's very difficult to dye these fabrics in large volumes, and it's the same for CO2. So the limitation is not so much that you can't dye it, you just can dye less of it. So you have a capacity reduction, so that drives up the inefficiency of the machine if you do only taffeta fabrics, yes.
Do you guys have any future plans to incorporate functional finishes through the CO2 process?
Yeah, ultimately we think that a lot of processes, either pre-treatments or post-treatments, can happen in CO2 and in supercritical CO2. At the moment, the focus for us is purely to develop the technology further for dyeing. Hopefully in the coming years we will see other people picking up other areas of interest. Technically, CO2 is capable of doing that. The thing is, if you broaden that whole span, you need to have a whole range of different machines in development, and at this moment for us the focus is only on the dyeing part, but we do work with different chemical suppliers in developing finishes purely for CO2, yeah.
Can you dye different mixes, I mean like polyester cotton, polyester viscose, or only 100% polyester in every batch?
At this moment you can dye anything that contains polyester. Any blend with any natural fiber you can dye. We only dye the polyester and we leave the rest of the natural fibers unstained, so you can do very nice melange effects with it. If you dye blends with polyester spandex, there you do need more post-treatment to actually retain fastness properties. For us, that might be possible in the future to do that all in CO2, but at this moment the technology is not ready for it. But there are alternatives where you can actually use no water technologies to actually remove unfixed dyes and still have a 100% water-free process.
With polyester, dope dyeing is now also pretty common. So how does your process compare with the dope dyeing process for polyester?
They are fully complementary to each other. They both serve a different part of the market. So dope dye will always coexist with regular yarn dye, and it will always coexist with CO2 dyeing. We can even combine dope dye with CO2 dyeing. In some cases with dope dye you cannot retain very dark colors, or very black colors. If you combine it with CO2 dye, you can actually get to that dark shade because we can actually deliver more dyes into the yarn because we use different method of delivering it. We do work with customers where we actually use dope dyed fabrics combined with CO2 dyed fabrics to create melange effects. So in our case, it It works both ways. Of course, there are business cases where dope dye is the most preferred technology. If you never change a color, why would you even consider using a dyeing technology, whether that is without water or any other method?
Independence of the quality of the polyester, can you expect some damages due to these pressure effects, if you have small bubbles, micro bubbles, air bubbles inside? If you release the pressure, can you get damages?
No. So just to take away one misconception, the elevated pressure towards 250 bar operating pressure is just to create an atmosphere. That atmosphere is absolutely not required for dyeing, but we need that atmosphere for the CO2 to become supercritical. The dyeing itself is generated by a flow of CO2. And in that flow of CO2, we have an internal motor and pump that will pump the CO2 through the fabric, and that creates a pressure difference. So pressure has no effect on the material itself. So basically, CO2 is inert to the polyester, and it leaves it completely intact. Even if you put additives into the polyester, for example, flame retardants, there's no change in quality there. The performance is still exactly the same.
And the last question?
Are you guys able to do like piece dye and color variation with this technology without affecting the color tones? Like multiple pieces?
Sorry?
Like piece dyeing with different fabrics, like kind of off his question with the different woven fabric materials, piece dyeing it with this, with multiple colors?
At this point, well, with any dyeing technology, it's a unique color, so we cannot differentiate in applying different shades on different parts of the fabric. That's not possible. You can combine it with different dyeing methods. We have people that want to use double dye and use polyester dyeing for the polyester phase and then use standard reactive dyes for cotton. That is possible, but in our case, we cannot differentiate in shades or make patterns with it. No.
Thank you,
Okay,
Mr. Nossent.
thank you.